All right, please let's continue from where we stopped on the topic rounding, approximation, and estimation. Still on the course of pharmaceutical calculation. Which question do you have? Ask.
Sir, when you get like 12 million as your actual value, can your estimated value be 12 million 100,000?
See that? He asked if you get 12 million as he said if you get 12 million as your actual value. Let me tell you, the fact is this: numbers you estimate, and those numbers maybe you don't. If you see it, you cannot be given the number that you just look at pound. You know the answer, 3 pounds. That was it. And then what are you estimating? Nothing there now. You see what it is. I'm not computing. Most of this number that is somehow in this form, where maybe you want to estimate it first before you start doing actual calculation to know where it will get you to. Am I computing? If you have some, if I gave you 12 million, 6, maybe something that can easily give you 12 million as estimation. They're not even estimating there again. Hello? Because it's too direct, okay? It's too direct that you can't even be given such number for you to do what? Estimate. Why? I can't give you anything you are being given in calculation is a problem. Hello? Anything you are being given in calculation is a problem to solve. Now, if I'm giving you what is so simple, it's not. I'm not happy. It's not. You are doing nothing. That's why in calculation we call it what? Problems. And if you want to answer the problem, you say what? Solution. So if it is too simple, is it a problem? It's not a problem now.
So you have not answered my question. My question is, can the estimated value be 12 million 100,000? Sorry.
You can't even be given such. It's not a problem.
But it's like.
You can't even be given such because it's not a problem. So why are you stressing yourself?
Okay, let me give you another question.
Get again here. What's the problem?
Can you give me problem? Keyboard well. Eat the child is well. Hello. No, this is classroom. I taught you something. You should do what? Solve it. Let me know what I taught has entered. Okay, yeah.
Actually, can you send video estimated? Can you send video estimated?
This HCC there is most times estimation. Let's assume you have something that this number that is somewhere here. It's look more like estimation, but this look more like what you just look at, just what you just configured on your own and put. It doesn't look at the estimation. You look at what you just configured and put.
So you need more problems.
Solve it. Apply what I've taught you now. There, let me see. Apply it first. Start solving what I've said. Let me see what you got. For what?
This is the actual value. This one is estimated.
What's this one? You have 3 zeros here. 2 zeros. What do you want to write? Let me see.
12,000,000.
Kosi, do you know what is place value?
Yes.
What place value is this one here? This one there.
This one is 1,000.
This one is what?
1,000.
Oh, yeah. Estimate it. Estimate that thing. You are saying something. 12.4 million, right? Yeah, yes. You can estimate. Yeah. No problem. Let me see how you water to then.
Jesus.
Before estimating. That was to give you an idea of the estimation. 12. I have multiplied like that. 34 and 40.
All right, thank you. You have tried. Go and sit down. Now let us now. Where is the cover of this marker? Okay, sorry, I'm with it. Okay, now we've had an overview of this topic. Now let us go to let's go to what? Business. Let's go to what? Business. Let me see your course materials. Get your course materials on significant figures. We have not treated the topic. I told you that we are doing an overview of what you expect in the world topic. So that if you are studying on your own, for those that study ahead, as you are studying now, it will guide you exactly what you are expected to. Maybe there's a material you want to consult to study, to read these topics. Whatever we did today will be a guide to you, what you should look out for. Okay, that's the meaning of what we just did now. So we are now going. I told you that under the rounding, we treat what significant figures and what decimal places. Hello. Now, please, I want us to get our course material on significant figures, please. Get your course material on significant figures. The title of the material is significant figures. Yes. These significant figures in Abayale, Chinenya. What are you doing there now? Listen. God is a just God. God is a just God. Take it or leave it. He is happy with what I'm doing because I'm disciplining people.
Yes.
Your parents paid. Your parents paid for discipline, for to be disciplined. How can you be in a hostel and look at the behavior? Does it make sense to you? Chukwu will be happy that this man is doing the right thing. I don't care what you think or what you feel. I may not chase you away in the class. No, I may not do that. But now let's go. Now, these significant figures, you've been hearing significant figures from your primary school.
Yes.
But you've been dealing with abstract what? Numbers. Now you will start dealing with what? Denominate numbers. You start hearing some things that may be contrary to what you've been hearing from your what? So some of you may even start arguing. By the time we talk about significant figures now, so some of you may even start arguing. But I want you to know that what you are doing now, what you did in your general mathematics are just what? With abstract numbers. It's not trash. It's a foundation. It's not a trash. It's not trash. Because if they start saying what I'm saying now, then you won't understand it. So it's step by step. Education is step by step. That's why you keep doing the same mathematics, the same topics, but not the same way. As you go, as you grow, as you go higher, you start seeing different aspects of addition that you didn't know before. When you are in your primary school, primary 1, if they are adding, isn't it like minus 1 plus 1?
No. Yes.
Primary 1.
Yes.
Primary 1. What are you saying now? Primary 1. Primary 1 knows a 1. Isn't it minus 1 plus 1? They will never understand it. They will never understand it. The only addition they know that time is just 1 plus 1 plus what? The very first day I heard minus, I was like, what is this woman talking about? I was just rationalizing what she was saying. I was, this woman, what is he saying? Picture is minus again. What we did plus, he's telling us minus here again. I didn't understand what he was saying. I was even somehow, what is this woman even saying? So it's step by what? Step. So when I realized that minus has come to stay, was when I came up and said, man, you must go and learn this minus. Now, when I started learning that time, she was telling us, if you have 2 oranges, and if you are owing somebody 1 naira, and you have 2 naira in your hand, how much do you have? I said, the person has 2 naira. I said, no, which one is your own? It's 1 naira. The actual value that is your own is what? 1 naira. You have a big shop. We have up to 1 million naira worth of drugs. Big pharmacy, or 5 million naira worth of drug, and you are owing your supplier 3.9 million. By face value, hey, this man will go. Hey, this man has money. But within you know say you don't get shisha. Maybe your sister will come. Uncle, we are told to 500,000. He will look at you. You are in the shop, he's selling. People are bringing millions of naira. But the money there that is his own is maybe around 800,000. You come and tell him that we are told to bring what I say, I see, okay. Negaro, scripture is Negaro. I was here now, they gave him 1 million naira. Negaro, how? You won't understand. You gonna get bigger. The money I brought here. So he's owing minus plus. So if you get only 800k, you know, say I go 500k. Now yala. He may not talk, but he will just look at you and keep quiet. Maybe Osigi Ngozi school bad. Ono one school ọzọ beto cheap ga-ele gị aka. Imo live on eche. Imo no na agbachi ime bi eche si awota ego akwụkwọ. So please, mathematics, not just mathematics, knowledge is what? Graded. It's graded, right? Then what you expose at a particular age, as you go up, it may not be exactly the same thing. Okay? When we were in primary school, I'm here for mathematics. That's why the first time I heard that in which is the further mathematics again? Further mathematics. Have I finished the mathematics I'm doing and saying further mathematics? It's a bit advanced. So everything is what? Step by step. Now, coming back to what we are talking about, significant figures. Yeah. Hello. Aman nama apa figure for Natabazian. Elizabeth Nataba. Come back home. Come back home. Come back home. Are we home now?
Yes, sir.
Now let's talk. Now, I want to read out what I have here. Remember, I mentioned count what numbers, right?
Yes.
I mentioned count numbers and give. What do I say now? Give. What do I say now? Gift. Come in. Gift. What do I say now? What did I say now? I beg. Did I say I beg? So what did I say? I come out. Ifulia. Omali yenku. On a class na amuamu. Omali yenku. No, that's bad. That's very, very bad. I gave like 1 minute for everyone to come back home. I know that now from some people. Those things are important in class. You ease off what? And come back. So, please, let's come back, please. We are discussing something important. Your eyes should be on your course material now. That's where your eyes should be. Because I want to read out something. To buttress whatever I'm going to read out now will be a summary of a summary or putting in black and white what I've been saying here since. If you are listening to what I was saying on the board for the past 1 hour or so, I want to read it out now so you understand it better. For those that want what is in black and white, you know that people that unless they see it written down or read, they won't understand. If you explain from now to tomorrow, you're on your own. It will be abstract to them. Now listen, remember I mentioned count numbers here, right? Yes. I mentioned count and approximate, right? Yes. Good, now let's go. Now when we count objects accurately, every figure in the numeral expressing the total number of objects must be taken as its face value. I discussed face value with you, right? Yes. Isn't that when you count objects as a human being or whatever you want to count, you have stones. About 10 stones here. You count them. 1, 2, 3, 4, and got 10 stones or 9 stones. That 9 should be taken at its face value. What do you mean that this is what it is? It's 9. There is no hidden whatever. That is what 9. It's not approximate. It's what 9. Now, that's what this first sentence explains. It said, when we count objects accurately, every figure in the numeral expressing the total number of objects must be taken as at its face value. Such figures may be said to be what? Absolute. Did I mention absolute here?
Yes.
Such figures are said to be what? Absolute. Now, in contrary, when we record a measurement, the last figure to the right must be taken to be an what? Approximation. An admission that the limit of possible precision of necessary accuracy has been reached, and that any further figures to the right would be what? Would not be significant. That is either meaningless or for a given purpose needless. Now, see what we mean. You know, if you measure, let's assume you weigh or measure, as the case may be. First of all, if you count nine tablets, let me be using pharmaceutical terms. If you count 9 tablets, it's 9 tablets. There is nothing less, nothing more. It's 9. Then there is 9. They're not like appropriately 9 tablets. It's what? 9 tablets. You counted it. Now this is absolute. Now, but when you now maybe you want to measure, you want to weigh. You want to check the weight of this 9 tablets, for example, now, and you have something like, for example, now, or maybe weight of 1 tablet. We have 325 what? Gram. Are we together? Good. Even though, if you just look at it, from the face value is a count number, right? It's a count number, right? But it's not a count number. This is an approximate number, even though it came from what? Measurements. Are we together? If this doesn't have any units, if it's abstract, you can simply say, okay, it's a count number, right? But the unit it has, this is a measured quantity. Why this is a count? Do you measure tablets?
No.
Do you measure the number of tablets?
No.
You count number of what? Tablets. But you measure or weigh the weight of 1 tablet. True or false? Now, this number, this value here is an approximate value. It came from what? Approximation. Now, the first digit, second digit may be taken at their face value. But this last digit, what it means that there are other small fractions that we are permitted to get what? This 5. It's not just 5 you are seeing as the face what? Value. Now let me continue reading. Now, a denominate number, second paragraph. A denominate number like 325 gram is interpreted as follows. The 3 means 300 gram. We are applying place value here. Neither more nor less. There are nothing less added to it, nothing to move. It's 300 gram. That's what it's done. Now, the 2 here actually means what? 20 what? Gram. Exactly 20 gram more. That's on top of the what? 300 gram. But the final 5 means approximately what? 5 gram more. Approximately what? 5 gram more. Approximately what? 5 gram more. Do you know what it means? What it means is this: 5 grams plus or minus some fractions of a what? Gram. Some fractions of a what? Gram. Whether this fraction is for a given purpose, negligible, depends on how precisely the quantity was what? Weighed. Now, this is where the issue lies, on this last 5. This is an approximate what? Value. And what value of this depends, you now consider what should be here. Consider the what? The accuracy of the measuring instrument you are using. the reading accuracy or the precision of the measuring instrument you are using. Any measuring instrument in the lab. Let me use weighing balance. You've done your practical, right?
No.
You've not done any practical in lab.
Yeah.
So what did you do last week? Thursday. By the time you start the practicals now, if you get the weighing balance there, each weighing balance, if you look at it, not just calibration, they have their what? Reading accuracy there, or precision as they call it, depending on the one they call it. Precision on some may be 0.01 gram, some may be 0.001 gram. These things depend on how sensitive the instrument is. Depend on how sensitive the instrument is. What he's saying that this thing has a lot to do with this last 5 there. This is where this approximation comes in. What it means that this last 5 can be plus if the reading accuracy of that instrument is 0.01 gram. That means that last 5. Let's assume the instrument used to measure it is the reading accuracy of it is 0.01 gram. That means this last 5 is actually 5 gram. 5 plus or minus what? 0.01 gram. What it means is that it's a range. 5 plus 5.01 gram to what? 5.5 plus 0.1 gram. 0.1 gram is what? 5 plus 0.1 gram. Now 5 minus 0.1 gram is what? 4.99 gram. That means this 5 here, depending on the reading accuracy of the instrument you are using. If it is 0.1 gram, that means this 5 here is a range from 4.99 gram to what? 5.01 gram. So it's an approximate value, which they now approximated or round up to where? Depending on if it's from here to here, any number, it can be any number it can be 4.99, 4.99, 4.9, 5.00, but at the end, it should be within this range. So this number here is what? An approximate value, but it has a lot to do with the instrument you are using weighing the thing. What it means is that this is also in another way, this is an estimated error. This is also a kind of estimated error that you can encounter while using this instruments. Is also an estimated. Now most of these instruments you are actually, if you want to write down the measurement, let's assume you measure this should actually be 325 gram plus or minus 0.1 gram. This is the correct way of writing this measurements. Yeah, okay. This is the correct way of writing these measurements. If you did your physics well in measurements, you would definitely come across this in place. But with time, as we go forward, as we move forward, I will, okay. Any question?
What is the error range, like maximum or minimum, like plus or minus 0.01?
Based on this now,
Yes.
this instrument you use, that's the range. So if you now want to go to this thing now, if you weigh this thing now, what this actually means is this. I dealt with the last figure.
Okay.
So this actually means what? Add 0.01 gram to this. You have 32 5 point Then subtract this from this. You have 32 4.99 grams. So we have the range 3.2499 grams to 5.01 gram. This range. That's the meaning. Now I want to bring in the importance of decimal point and the significant figures here, the measurement. Now, please always note something. Note that the decimal points, the decimal places, not the number, decimal places. The decimal place of a particular instrument. Let's assume now a particular instrument that has decimal place that is really reading accuracy takes a particular decimal number of decimal places. If you use it to measure something, please, anything you measured, any value you got in measurement, should assume the same decimal number of decimal place of the reading accuracy of of the instrument. Let's assume now. Let me start from meter rule, for example. Now, if you have meter rule in cm, it can be in cm, it can be in millimeter, as case may be. If you have your meter rule, if you take your meter rule and measure a length with your meter rule, this one I'm saying now, and you tell me that you got 20.57 cm. See. Getting? See, it's not true. You didn't use it to measure. You don't do what? You don't use it to measure that. Do you know why? If you check your meter rule, who is meter rule here? If you check your meter rule, check the smallest division in that meter rule. The centimeter scale. Check the smallest division there. 0.1 cm, right? 0.1 cm. Now, the reading accuracy of this meter rule is what? 0.1 cm. The reading accuracy of this meter rule is what? 0.1 cm. Now, that means if you use this meter rule to take a measurement and it's in cm, you can never get 20.57 cm. But you can get 20.5 cm. You can get 20.6 cm. That's the import of decimal places in what? Measurement. The decimal place of whatever measurement you got must be the same decimal place with the reading accuracy of the instrument you use. That's why you remember in your secondary school, in your physics practical, there are some measurements that they will tell you to put it in 2 decimal places. There are some measurements they will tell you to put it in 1 decimal place. It's because of the reading accuracy of the instrument you use to measure that thing. So if you come in exam hall and you told me that you measured the length and you got 20.56, this is how to know those that manipulated their result. You not touch your, you will not even come close to your meter meter rule. Unless you are talking about calculated value, that one is so. Even after calculation, you will be told to put it in 1 decimal place so that it will be in line with what the unit of we are talking about. Are we together? But you can, if you say you measure a length, how many millimeter makes 1 centimeter? 10 millimeter make what? 1 centimeter. Okay. So this thing, so 20.6 in millimeter is what? 20.6 in centimeter is what in millimeter? 206 what? Millimeter, right? Good. Okay. Now, there are other measuring instruments now. Something like there are other measuring instruments used to measure length. Maybe all the small length. Maybe something like what is it called? Something like calipers, vernier caliper, something like that. I think for vernier caliper also the reading accuracy is around 0.01 cm. So if you use it to measure length, that's when you can get this. If you tell me that you use vernier caliper to measure length and got 20.57, I will accept it. It's true. Because do you know why? It's in the same decimal place with the reading accuracy of the instrument you do what? You used. That's an importance of what? Decimal place in what? With respect to the instrument and measurement. Now, if you are using a weighing balance, that's why I told you, if you go to research your practical, get the weighing balance you are using, go through it. You must see, so now you see where they wrote, there's one you may see where they wrote 0.01 gram. This is the accuracy of that what? Or the precision of that what? Weighing balance. Now, if you use it to weigh, you can weigh you can weigh a substance and your answer the value you got from the weighing can be, you can get 20 points, you can get 2.45 what? Gram. Is possible. Is what? Possible. Because once I see it, I will know that okay, the reading accuracy of this is what? That's why you don't approximate. Remember, we are this topic. This state of listen. Have you noticed something? That these state topics are, especially 1 and 2, these are rounding and approximation. 2 of them are what? They intertwine. Have you noticed that? You can actually get one separately and start creating. That's why I'm talking about all of them are at work the same work time. Now, if you are weighing, let's assume in pharmacy and other professional courses where you use denominate numbers, be careful about your what? Rounding or approximation, as the case may be. Be careful, because if you are supposed to work with 0.004 gram, if you get electronic balance, electronic balance, analytical balance can have accuracy up to 3 decimal places. Hello? They can have accuracy up to what? 0.001 gram. So you can actually weigh 0.004 gram using this instrument. You can actually weigh 0.576 gram. Now you go and start approximating. This maybe you are taught to weigh, sometimes weigh 0.576 gram of an active ingredient or excipient. You then go and approximate. If you then go and round up. If you round up and get 0.6 gram, do you know what you did? You use excess of that what? Ingredient. That's what you did. Have you seen why you should be careful with what? Denominate what? Numbers. Because what you are actually adding is excess active ingredients. What if that drug is highly potent? And what if it is a poison? It's highly what? Potent. That small amount of it elicits a very high what? Response. And the therapeutic window is so narrow. What are you going to do? It's a problem. That's why instead of rounding anyhow, look for the instruments that has accuracy, that can, or precision, that can weigh this way. You don't have it, don't even do it. Are we together? That's why if you go there, you have ordinary weighing balance, you have electronic one. These things, they have different what? Accuracies. Are we together? That is, I'm trying to explain. Remember, we are treating significant figures and decimal places. I'm trying to get the application of decimal places in what we are doing. So you see that it's not just to do decimal. It's not like that. It has application in what you are doing and what you are doing as a pharmacy or technician, as a pharmacy, in your weighing, in your measurement. So anything you are, if you use a particular, of course, you should know that the instrument there, each of them, before you start weighing or measuring, check the accuracy of what you are doing. What reading accuracy of the instrument. That's the first thing you should do. It will guide you to what you expect to get after the what measurement. So If I am the one handling your practical and you come and told me that you wait because you want your answer to look somehow, and you come and tell me that you wait, you mention the weighing balance you use. Tell me that maybe the accuracy is what 0.101. You tell me that I weighed this thing 0.576. See, it's not this weighing balance you use. It's not possible. You come and explain what you did. You did mathematics, even though we know. Let me not go to. We know how we do all those things. Those years. Okay, ask.
If you use a weighing balance,
okay.
And then you measure something like 0.567. Now, obviously, your answer should be 0.56.
2 decimal places.
He says
2 decimal places. Yeah.
Will you round up or you give the exact number?
You don't round up. Give the weight. Don't round up. Hey, don't round up. Let's assume you are doing practical. You are producing drug. You are actually producing what? Drug. And the formula says use 0.576 gram of. Let me write and use 0.6. You are adding more ingredients, which may be dangerous depending on the nature of ingredient you are adding. In fact, not even at that step. You are not producing what you are supposed to produce. There's a problem there. It must be the exact of what you are producing. What's that? Ask.
There is so it means that it's only that attitude that is the face value. That attitude of face value, that attitude now that.
You say you should be taken as their face value. What it means is that it's actually 300, or that's what it is. 300. Yeah, it's not approximate. You're taking like that. But this 5 here is an approximate. I don't understand your question. But you know what face value is?
Yes, I know what face value is. But when I like one and think that face value those normal numbers, they method and number like 1, 2, 3.
That yes. It's possible. If I write 10, with respect to approximation, that's what I'm talking about here. That this is the face value is actually 10. It's not an approximate value. It's 10. 10 is what it is. Yes. Now, so based on this now, we'll now go to define significant numbers. What are significant numbers? Sorry, significant figures. Now, significant figures are consecutive figures. Significant figures are consecutive figures that express the value. Significant figures are consecutive figures that express the value of a denominate number accurately enough for a given purpose. Significant figures are consecutive figures that express the value of a denominate number accurately enough for a given purpose. The accuracy varies with the number of significant figures, which are all absolute in value except the last number. Am I communicating? The accuracy varies with the number of significant figures, which are all what? Absolute in value, except the last. And this is properly called what? Uncertain. So this 5 here is what? Uncertain, okay? Now, 0 is a significant figure.
No.
Eh? Good. It's not a same number.
Yes.
It depends on the position. Simple. It depends on the position. 0 can be significant. It can be insignificant. Depending on the what? Position. Now listen carefully. I want to bring in significant figures now. I have explained to you whatever we are doing, we are linking it to our measure. Because after this topic, next time you see a thing like this, when we go into what measurements, we are linking these decimal places and significant figures to what? Measurements. Now, as we have the application or the implication of decimal places in measurements in significant figures now, by the time we start handling answering questions in significant figures, you start having issues with it. You'll be like, this is not what you were taught about significant figures in your what? Secondary school. I want you to understand that those two ones are what? Abstract what? Numbers. But when they are dealing with what? Denominate number that will become significant for you when you are dealing with denominator number depends on the purpose for which you did the what? Measurements. Depends on the purpose for which you did the what? Measurement. Now let's assume, and they are irrespective of the position of 0. Irrespective of the position of 0, as you say that the position can be depending on the hair. Now if you have 0.025 gram, 0.025 gram, is this 0 significant?
No.
Is this significant?
No.
It's not significant.
Yeah. It's not significant.
Now, but what is the role of this 0 now in this number? The position of the decimal point, right? Good. Now, what if you want to weigh? If you want to weigh, maybe paracetamol or maybe any ingredient now. If you want to weigh an ingredient now, if you want to weigh an ingredient now, using what is it called? A balance that has a sensitivity of 0.1. Can you weigh this thing accurately? An instrument that has a sensitivity of 0.1 gram. Can you weigh 0.25 gram accurately?
No. Yes. 0.01. No. 0.1.
Can you weigh 0.025 accurately with this?
No.
Please look for the one that has what?
0.001.
This may be all this analytic or maybe most of these electronic weighing balance have this. Now let us now go to some rules. Now, what I want to point out is this. You have mentioned it here now, that any 0 between digits is what? Significant. You have mentioned it here, right? Yes. That any 0 between what? Digits. So if you have 209. How many significant figures does this number have? This 0 between 2 and 9 is what? Significant. So this has 3 what? Significant what? Figures. Huh?
It's still
200. How? 2009. Are they significant?
Yeah.
Significant. 200. Hello, someone ask a question. Hello, someone ask a question. I think I like this your question. Look at this number. 200. These zero, are they significant?
Yes, that's significant. But if I'm 2.00, it's not. But this one is. No, but that's 0.00. That's 2.00. It's significant.
This is where the problem lies. In your normal thing you are taught in secondary school.
This one is not significant.
Are they significant?
No.
Yes.
In your secondary school mathematics, general mathematics.
No. Yes. Yes.
They are not.
They are not.
Check, Google it.
They are not.
They are not. But if you come here in your measurement, 200 grams, very, very significant. You can't leave it and go and start weighing 2 grams.
What of him is 200.9? 200.9.
200.9. What do you have to say here? Is what? Why? Why do you say so? You said it is easy. I'm asking, why did you say so? Is this? Okay, I thought you say. Okay, I thought you say it is insignificant. Okay. Now let's go to another point now. Okay.
This that 0.0251. After that decimal point, that 0 in front of that 2.5 is significant.
I'm coming. Now, another point I want to make is this. Hello, listen carefully. We say that any zero between digits is what? Significant. Now, another point there is that initial zeros to the left of first digit are never what?
Significant.
The initial zero to the left of first digit are never what?
Significant.
They are included merely to do what? Show location of the what? Decimal point. And thus give place value to the what? Digit that what? Follow. Chinaya, have I answered your question? Huh?
Initial 0 to the left
Have I answered your question? Hey. See, listen carefully. I want to give you a secret. I think, hello, listen. I think I've noticed that thing. When a lecturer, whether he's dictating or saying something, as that is entering your ear, try to do what? As fast. Try to be. Don't just be writing because you hear you just write it just like that. No, try to as you're writing it anyway. Maybe, but learn it. Okay, is very, very good. You don't just write something without synthesizing it in your brain. It's somehow to me. Okay? You ask a question now. I read it now. That's why you don't understand it. Look at this human being. What I just read now? No. Initial zeros.
That's in front of 2 feet 0 point. That's 0 to 5. The 0. I feel that 0 is significant. That's 0 in front of 5.
Now the next one says. The next one says. No nechenka kozanaga. Again, the next one says 1 or more final zeros. 1 or more final zeros to the right of the decimal point may be taken to be what? 1 or more final zeros to the right of the decimal point may be taken to be what? Significant. Now, be coming down, auntie. We are still coming. I want to give examples of all these things so you appreciate it better. Now, listen. Look at 12.5. How many significant figures? 3, right?
Yes.
Good. But you know that any non-zero digit is what? Irrespective of the what? Position, right? Right? You agree with me? Any non-zero digit is what? Significant. Irrespective of the what? Position. But zero being significant depends on the position of the zero. You agree with me, right? Good. Now, what of 12.256? How many significant figures are there?
256.
Can they hear there? What's not 5? Us, not 3. I said first is 12.5 is how many significant figures? This one, uncle. Sorry, 1.256. Sorry. How many significant figures? Good. What else? Now, listen carefully. What of 102.56 is what? This explains what I say, that any non-zero digit is what? Significant, irrespective of the what? Position. So whether they are before the decimal point or after, it doesn't matter. They are what? Significant. That answers the first part of it. Now the second part is talking about zero. Zero will now come in. 0.5. How many significant figures? He comes back to he brings John of is how many? Mm-hmm. I like her attitude in class. So much again.
So what of 0.005?
I'm coming. Now, here there is one word, significant figures. So that, okay, this 5 you are looking at there tells us how many tenths we have. Remember, 5, this is 5 what? Tenths is what? How many tenths do you have there? 5, right? 5 tenths, right? 5 tenths. So 5 over what? Right? Good. Now, the non-significant 0 you are seeing there simply calls our attention to where? The decimal point. Hello? This 0 before the decimal point calls our attention to where? On the way to decimal point is about to come. That's what that 0 there is doing. Even though it's not significant, because without that point, that's why it's wrong in pharmacy, in not just pharmacy, in any field you are dealing with denominate numbers. Don't you in your life write 0.5. Even though we know that in your calculator, if you point 0.5, you set to 0.5, right? That is abstract mathematics. But in denominate numbers, don't write 0.5. Do you know why? That 0.5, maybe you are working in a pharmacy, in a compounding room. You know, it's not the person that weigh that compound. True of us. Or the person, it's not the person that write out the formula that will weigh. Maybe if pharmacists may write out the formula, the pharmacy technician may go and weigh. I might communicate with another person. Then you don't go and write 0.5 gram. 0.5 gram. Some pen may not be that clear. They may not see that point. And they will go and weigh 5 gram. They make a difference between 0.5 gram. But how many times? So it's a problem. Do not write points. That's why he says here that this 0 is telling you, Oga, wait. There's what here? Decimal points. So cumulatively what you are what? Doing. Good. Now let's continue. Now 0.05, how many significant figures are there?
One.
How many significant figures are there? One. One, right?
Yes.
So the first 0 points, the 0 before the decimal point, calls your attention to the decimal point. The 0 after that the decimal point talks about the what? Place value, right? Of the numbers. Okay? The place value of this 5. That's why this 5 is different from that 5. The 5 is 0.5, is not the same place value with 5 in 0.05. 0.05. Because of that additional 0, this additional 0 is telling us that this 5 following me, or this 5 following me is in hundreds. It's not in 10 though. So you know what you are doing. Does it make sense? But it is 5 is the what? Only significant figure what? There. Am I communicating? Chinanya? Has the question been answered?
Yes, sir. But what if we have 0.005? Like the 2 zeros after.
I think someone asked a question. Or you get something. So what's the problem with it?
Like, is it still only that 5?
Yes, it's only that 5.
What if, like, in that 102.56, what if there is 0 at the back of C is there? Is that 0 there insignificant or significant?
At the back of 6.
Yes.
We are coming. Just let's do it step by step, okay? We are coming down there, okay? Just listen, we are coming down there. Then let's look at this one. What of 0.005?
1.
How many significant figures?
1.
1, right?
Yes.
Good. Stay 1. What of 0.65?
2.
How many? 2 significant figures. 5 and what? 6 and 5. Okay. What of 0.065? 2 again, right?
Yes.
0.065 is 2. What of 0.0065? 2. Please, I want to call our attention again. If you are following this lecture, 90% of or 60% of what I'll be saying are not here. I hope you know.
Yes.
So, and if you play with them, you will see it. Some you will not see some anywhere. I'm not lying to you. Some you will not see some anywhere. So if you miss it here, you have missed it. Unless you recorded it and go and listen to it. So take this lecture seriously. So you can not lose attention, lose focus. Okay? If you are feeling sleepy, stand up. If you are tired, just stand up and walk around. I'll permit you. Just walk around here. I'm listening to the lecture. Now, next one says 0. Okay. This one is also what? 2. Now, I want to go into something new now. Let's see how it goes. Even though I mentioned it, but let me know those that are listening to this. Even though it's, why do I always keep this in like this? Now, what of this one? 0.0605. How many? 3. Why 3? Well, that 0 is between what? So it's significant. Good. Now, here now, as you said before, the first 0 calls our attention to the what? The first 0, this 0 calls attention to where? Okay. What did I say now? What did I say? Tell me what I said. So after that, what else did I say? Answer me again. And don't was now. When I now go to internet thing, when you see a fear, same sir, what do you say about this thing? That's the problem. Now, I said that this 0 calls attention to what? And in that material again, you also see the second 0. Can you see there? Shows the what? Number of places to the right of the what? Decimal point. That is the place value, right? Good. Occupied by the remaining figures. The number of places of the decimal point occupied by this number, this 605 are their place what? Value. So this second one shows the place value. This one points at this, tells you the decimal point here. This one tells the place value. Okay? Please note these functions of these zeros that are not significant. They have a role they are playing there. They are not just there for being there. They have important role they are playing there. Now, okay.
That means that what about that 0? If you want to call it that tension, and after
which test 0?
Like that 0.005. The first one I call attention for decimal point. That one I call attention for place value. What of the next?
The same thing. Yes, the same thing. Yeah. Any 0 between the decimal point and the first digit. What's going below? 0.001 million zeros before 1. All of them are talking about the place values of the following what? Digit. Chinanya, you know now. Keep now.
If not any 0, so then you have to do 0 after that decimal point. Now you pay attention to the place value.
Of what? Of the following what? Digits, not digits. Of the following non-zero digits. All right. Now, look up. The third 0, we are explaining this in detail now. The third 0 significantly contributes to the value of the number. It's significant. This 0 now is what? Significant. Because it significantly contributes to the value of what? The number. Listen carefully. In a nutshell, when a number is significant, you can never in this life ignore that number. If you ignore that number, you have messed up. When a digit is significant, you don't ignore that digit. But if you ignore the digit, you have messed up the number. You can never get the value of that number again. Am I communicating? Yes. So you cannot ignore this 0 between 6 and 5 here because it significantly contributes to the value of this one number. That's the meaning. That's the what? That is the meaning. Now, I think Chinaya, we are about to answer your question now. Let's take a look at this one. 0. What? 0650.
4.
How many sigma figures? 4. Do you know why?
Yes.
This 0 also contributes significantly to the value of this number. Watch out. If you want to move this number down to fraction, watch out. You want to move this number to common fraction, watch out. You have what? 1. You must put this one too. If you check ever. So you contributed to the value of this number. True of us. But this one did contribute. You have cleaned it. Is it clear now? You have cleaned it because this one is only talking about the absolute value. It's not contributed to the value of this non-significant. So you clean it up. But this one, you don't clean it. If you clean this thing, it becomes what? So now, please, let's note this point, okay? Even though when you start reducing to the smallest, it cancels out, but it still has value in the one number. Is it clear? Yes. Good. Now let's go. Now, okay, there's something I want to point out here. It should be noted, however, that in pharmacy practice, trailing zeros are not retained as a result of a calculation, as they may lead to misinterpretation and error. There are 2 zeros you should be careful about. Leading 0, have I mentioned it in this class before?
No.
Leading 0 and what? Trailing 0. Leading 0 and what? Leading what? 0 and what? Trailing. Leading 0 and trailing what? 0. Now, in pharmacy practice, you must always include your what? Leading 0. That's what I explained here. When I say 0.5, okay? Like here, you don't write 0.01. This 0 before the decimal point is what? Leading 0. If you have something like this, let me use this as an example. We have 0.0605. 0.0605. This 0 before the decimal point is what? Leading what? 0. This 0 after 5 here is what? Trailing what? 0. Remember I said that you must always include your what? 0 to avoid trouble. I told you what it can do in compounding. So you must always include your what? 0. Avoid trailing what? 0. Avoid what? Trailing what? 0. In pharmacy practice, when you are actually compounding, even though it is significant, even though it is what? Have you seen the reason why I say that whatever you retain in your measurement depend on the purpose for which you want to do what? Am I communicating? Yes, it's significant, but in pharmacy practice, don't include it. It can lead to what?
Error.
Wait. Just wait. 2.0. Hello? 2.0. 0.065 what? 0. In your normal calculation, if you press 0.5060, does this thing have anything to it will disappear, right? What of this one? Will it also disappear?
Yes.
Huh? Now listen carefully. Be careful about these two zeros when you are dealing with denominator numbers. If care is not taken, especially when someone fails to see this point, it will be taken as what? 20 grams. So the person will start from 2.0. Instead of measuring 2 grams, the person will measure what? 20 what? Gram. Are we together? Good. That's what you are trying to do what? Avoid. Now here, if you have 0.650, if care is not taken, the person may measure what? Especially when they are, anyway, this one can still be measured because at least before you look at here, you would have seen that this is under what? 6.5. But if there's any mistake and the person did not put this thing, or maybe anything that happens that the person starts measuring 650 more, maybe if person has 0.650, that one is even the worst. Instead of weighing 65 or 0.65, person will even multiply it by 100-fold and start weighing 650 what? Gram. As against what? 0.65 what? Gram. But as a rule, remove trailing what? 0. Put leading what? 0. Simple rule. If you are actually doing compounding, you are the denominator number you are working with. You are actually weighing something or measuring something. You want to measure out a particular quantity of that thing in what you want to compound. Avoid what? Trailing 0 and always put your what? That's the golden rule. What is it?
So what is it? As when you add that trailing, what is it?
I've explained it here now. No, you are not there. You are not there. But you are there physically, but you are not there. I'm coming.
So you said the other one, you said that this Z is significant because it adds this thing to the number.
Yes.
And you said again in pharmacy practice, this one is the same one.
That's the problem. Did you mention it here?
Yes.
You don't listen. That's the problem. Go and sit down. Go and sit down. Before I started this topic, I gave a warning. I said, by the time we enter this topic now, you come out here and start arguing about what you know before and what that we are dealing with what? Denominate numbers. In pharmacy practice, what number are we dealing with? Is it abstract?
No.
I say even though they are significant, but when you are weighing something, I told that you are not the person to weigh. The person that will write out measurement, the person that will write the formula, maybe the what? The point that it's not the. If you go to, have you ever entered the production? Okay, I think you went to that. Weighing room is different, right?
Yes.
Where they get the formula, maybe a different office. You move from stage to stage. Now you are the one to write the formula on paper. Instead of putting trailing 0, instead of putting leading 0, you go and you remove leading 0 and put 0.5. You wait just here, it commits in kekanke. You wait just here 0.50. You just remove here leading 0. Wait easier what? Trailing 0. Or 0.50. The person will now go and weigh 50 grams. When you imagine yourself 0.5, try to do. I'm going to go just measure 50 grams. It's trouble. It's a very big problem. But they may not see that point. Some of you enter class here and I'm making notes when lectures are going on. You go name here a class they could be about all there. Okay, now what didn't you can know away nonsense. No, these things, their attitude. Their attitude, they form you. But you won't know. Entering class and making noise is very wrong. You think it's just about class. No. Anything you are doing here, try to relate it to what will happen after here. If you are used to, you can see, instead of staying in class and making noise, if you are not concentrating again, take permission and do what? Go out quietly, relax, and come back. The same way you are walking, it can happen to you when you are walking. You are losing concentration. Stop that thing you are compounding. Just stop it. So far you have not mixed something. Stop that way. Just stop it. Just go out first. Relax yourself. Come back and continue. Human brain fire. Sometimes what you are saying with your mouth is not what you are writing.
Yes.
Sometimes what you are seeing is not what your brain is interpreting.
Yes.
It happens once in a while. And once you notice that, go and rest. Leave that place. Relax yourself somewhere. Then, if you come in, you come with a refresh. This thing is better. I know about all this. That's why I tell my students, record my lecture. Because I know, even if you are the most, you comport you comport yourself. Once in a while, you lose focus. You can leave your phone into recording. Just go out and rest. When you are calm, when you're okay, you come out and sit down. After lecture, you bring what you recorded, and then stay here and making noise. It's wrong. Some of you, the genesis of this noise you are making is that you have lost attention, you have lost concentration, but because you don't know how to manage it, you are in class looking for who to talk to. You don't even know what you are doing. That's the cause. Once you know that your attention has started leaving what you are doing, just take permissions, go out. 5 minutes, 10 minutes, come back. Even now you come back with a renewed this thing to class. Please let us keep that at the back of our mind. It's very important. Ask. Huh? Okay, someone asked, what are denominate numbers? Oh yeah, answer it. Chineye. Numbers that have what? Units are denominate numbers. Okay? They have a specific units. Denominations. Like now if you say 20. You have 20 naira. 20 kobo. These things are denominations. The number has been, ordinary 20 is abstract. But 20 naira, 20 gram, 20 kobo have been denominated. They are what? Denominated. Because that thing, they have something they represent. It's not just ordinary number. That's why you don't approximate them like that. If you say 20 gram, 20 gram of what you say here is 20 gram of something, which may be paracetamol, which may be anything. Drug. So that was that. Be careful about how you handle them. That's why we are pointing at all this. We are pointing here. If you are, some of you, if you're not taught this, that you go and think you are dealing with abstract numbers. That's why when you write exam in PharmCalc, write exam in pharmacy, dispensing practical calculation. In the university, dispensing is 60% pass mark. In any pharmacy school, anything dispensing, my PharmCalc, anything BDT, anything that has dispensing, pass mark is what? 60%. If you score 59, you fail that course. In Maria, because you need to be close to what? Close to what? Perfection. Because these things are drugs we are talking about here. It's not ordinary number. That's why if you make any mistake, they are nothing like mark it step by step. I am unable to step by step. There's no step. You must get your answer. Because if you fail it, what it means is that bring it in real life scenario. You are compounding. You may be saying a calculation. We are supposed to calculate and compound 20 grams of particular medication or drug. You go and say, the marking step, and you get 5. That means you package nonsense. It's a serious thing. It may sound, but it's very serious. So there's no room for mistake. That's why I am very, very strict when it comes to pharmaceutical. I don't look at your face because I know the implication. You must learn how to, even though nobody is perfect in this life, you must learn how to strive to get to that word, perfection. Because these things are human beings that will consume them. It's human beings that consume them. So they're nothing like, is it because I didn't write the units, he failed me? What are you doing? So if you are the one that is writing, measuring that, you don't write the unit of what you measure. How do you know it's male or milligram that it's confusing? Or maybe instead of saying 20 milligram, you go and write 20 mil there. Then when somebody now want to go and compound it, what is going to, you go and you start looking for the So let's take note of all these things. It's very, very important in everything we do. So that one is what? I think I've mentioned about the what? The trailing zero, right? So we've talked, and forgot that we have quiz to serve. Even Emmanuel said, You say what? Hello. Someone said, listen. Someone said, now 2 hours go. 2 hours. But see, it's not just about the 2 hours. It's 2 hours. It's not just about 2 hours. Yes, I said it, but sometimes you have to face reality on ground. It's not about, unless you are. Why I say 2 hours is because I know that within 2 hours you need to do what. Are you there? Now, based on that, I think most of you are losing concentration already. Thank you. Most of you are losing concentration. What's that? Her quiz. Where are you going to with your bag? Okay, Chine, be there for your brother. All right. So I think we'll just do quiz and go, okay? We do quiz and go. Chisom we do, then 8 people will do. Is it what I said? Okay, tomorrow, no problem. She's ready. You're ready? Okay, hello, okay. See what you do, You know there's no time. And two people are ready now. So the 2 people will do their own. Hello. How boy am I going to? How boy am I going? How boy am I going? They were saying, let's do it now. No, see, take that boy am I going? Who does it, man? I want you to take this quizzes this thing we are doing seriously. Listen, as I told you, due to my other administrative work I have here, my prayer is that we complete this thing in 11. 11 quizzes before we write the exam. That's my prayer. But why it's good to be always make sure that each one even with a good mark in here is that we may not complete it. We may not complete it. If I keep going and coming, okay, now next week, the finalists are writing council exam. Then you see that. I don't know how that next week will be. I may be engaged in. Yes, it has always been like that. No, it's not here. Unless I was able to squeeze out time, then come. If not, that means Tuesday to Thursday is off. You see how time is going. And when it is almost time for it, you see that I may not remember to start doing quiz again. I may focus on what? Teaching. You see that if you have been scoring nonsense scores from the beginning, you see that you've lost that 20 marks is shaking for you. So start from the day one and take it what? Seriously. Don't say when I will now do another one, I will write well. Start with the one we are doing now. Start scoring high. Start taking it seriously. It's as simple as that. All right, so we end our lectures for today here. So we'll just do the quiz and go. All right, thank you. God bless you.